Welcome to this tutorial on predicting wine quality using machine learning. Today we explore a real-world data set, pre-process it, train models, and evaluate performance. By the end, you'll know how to handle imbalanced data, interpret feature importance, and compare different machine learning models. So let's get started. So before we start, there is a focus on the business questions. So for this business question, we're focusing on the business intelligence and data analytics. So business intelligence is focused on what happened and data analytics focus on why it happened and what could happen. So for this business question, business intelligence will be which wine quality ratings are most popular and commonly purchased by customers. And for the data analytics, we have two questions. Which chemical properties have the strongest correlation with the wine quality ratings? And can we predict the wine quality based on its chemical composition using machine learning method? Second, we have exploratory data analysis, which we're handling the missing values and outlier verification. So without further ado, let us get started with the tutorial. First up, we are required to upload the wine quality CSV file format. And after uploading the wine quality data set, we import packages for the following purpose: for the data manipulation, mathematical operation, data visualization, and graphical plotting. After importing all the important packages that we required, we'll have to load the wine quality data set. For this output, we can see that it is noted that the input attributes are in numerical forms and the prediction in this project will be the quality attributes. Next up, we have the data type info. From this data type info output, it can be seen that it contains 6,497 entries, and from the data type info, majority of the attributes are having data type of float except for one attribute which is in object type, and the output attribute quality is an integer data type and can be read as classifier or regression since it is in particular range. After getting the information, let's just get also the statistical info. And from this particular statistical info, we can retrieve some important information that can assist us later on in the exploratory data analysis. So the provided overview will be, the first one will be count, which is able to assist us in detecting the missing data, which is count versus the data set size. As earlier we noted that it is having 6,497 data set of entries, and if it's any of the attribute is lesser than that, it can be noted that there's a missing value contains in that particular attributes. Next up, we have the mean, which we identify the central tendency, and for a measure of data variability will be the standard deviation, and outliers detection or errors will be in the minimum row, and first quartile will be 25%, median or robust to outliers will be the 50%, third quartile will be the 75% row, and last but not least is the max, which able to detect the outliers and also tell us the extreme values. Next up, we have the preprocessing of the data set, and this we are able to detect if there's any null value for the following attributes. As you can see from this output, there are several attributes contains null value, and it is a total of 7 attributes that have the missing value. So what we need to do with this particular missing value is next to fill it up. So filling the missing value, we utilize the mean values. So after utilizing the mean value for all the 7 attributes that having the missing value, it can be noted that there's no missing value available after this. Next up, we'll have the exploratory data analysis, which will be utilizing the box plot creation. For this box plot creation, we are able to detect the outliers, can have the informations like median or interquartile range for the central tendency and variability. So for this particular of box plot creation output, we can note that outliers are detected from majorities of the attributes, and it is important for us to eliminate these outliers to improve the accuracy of our model. So the assumption is these outliers do not affect the outcome of our project. And next, we'll be creating the distribution plot. So for this particular distribution plot output, it can be noted that there are outliers detected from few of the attributes which can be removed. So normalization with the utilization of log transformation can be performed for the free sulfur dioxide here, which is quite right skewed. Next up, we have the log transformation. And for this log transformation output, it is capable to make the highly skewed distribution to less skewed and also improve the model accuracy by helping to normalize the distribution. So the large values are compressed and provide a more symmetric distribution. Next up, we'll have the exploration of the data set count in different types of wine. So this able to assist us in identifying the class imbalance if one type dominates the data set and express way for categorical data exploration. So this is the output, and from this particular output here, it is noted that the majority of the data sets belong to white wines. Next up, we'll have the exploration of the wine quality range, and for this, it able to provide us some information if the data set is balanced, and it is also crucial for the classification task. And for this distribution of wine quality output here, you can see that the quality range score for this data set is between 3 to 9, with the middle class have the higher counts. And next up, we'll use the plotting heat map. For this heat map, we are able to identify any redundant features and provide us guidance in selecting the feature for machine learning models. And just for your information, high positive value in the heat map indicates strong direct linear relationship, and high negative value indicates strong inverse relationship, and near zero will be weak or no linear correlation. So this is our correlation heat map for this particular data set. And for the description of this correlation heat map, you can see that a positive correlation can be seen from the quality attribute with the alcohol. So another positive correlation is between free sulfur dioxide and total sulfur dioxide. Last but not least is the negative correlation are the density and quality with a value of negative 0.31. Next up, we have the feature engineering, which we plotting the bean qualities into the categories of the poor, medium, and also excellence. So this is the output of the wine quality categories. As you can see here, medium dominates the other two quality category. And next up, we will have the one hot code that avoids the ordinal bias compared to the label encoding. Next, we'll proceed with data balancing and splitting. So visualization of the class distribution before we applying the smooth technique. So first up, we will highlight the imbalance. So from this particular class distribution before balancing, we can see that the data count value for each classes is shown, and we can note that the medium quality dominates and bias projection detected toward the majority class. So let us fix this imbalance with mode. Okay, so this will be the coding for the mode, and we balance the class and also verify the balance. And the output here, we observe that all categories are now having equal representation. So it is proven that mode is capable to create a synthetic samples for minority classes. So before we start with any training, it is important for us to split the balanced data into training and testing data set. So this will ensure we evaluate the model on unseen data. So the training set here will be 11,191 samples, and the test set will be 3,731 samples. Just a tips, the random state is crucial to get a consistent split across the run. So with balance and split data is ready, we can proceed to train our models. So comparison that will be made involved will be the logistic regression, decision tree, and random forest to identify which model handles the engineered feature the best. So before we start with the training, let me share with you the justification of the usage for these machine learning models. As we can see here, three machine learning models are selected: logistic regression, decision tree, and also random forest. For the justification on the logistic regression will be a baseline model for the classification task, and it is simple and interpretable. And it worked the best with linearity, separable data, and fast training. Cons will be its poor outcome on complex relationship, and it assumes linearity. As for decision tree, it is capable of capturing non-linear relationship and no feature scaling required. It works well with both numerical and categorical data, and is easy to interpret, and it's quite sensitive to small data variation and prone to overfitting. Last but not least will be the random forest, a reduction of the overfitting and handling non-linearity and feature importance. It is high accuracy and robust to outliers, but it is a little bit slower than the logistic regressions. Now, that's all for the justification of model selection. Let us start with the training. So first, we initialize the model with some reproducible random states. We have the trainings, prediction, evaluation, and we visualize our result through the confusion matrix as well. So this is the result for the logistic regression. As we can see here, the accuracy value is 0.68, and this is the confusion matrix. Next is the decision tree. So decision tree here we can see that the accuracy is having 0.85, and this is the confusion metric result. And last but not least is the random forest with the highest accuracy result of 0.93. And next up we'll focus on the cross validation. And as for the cross validation result, we are assured that the cross validation confirm that the random forest generalize well compared to the others machine learning models, which is the logistic regression and decision tree. Last but not least, we plot the feature importance for the random forest. As we can see here from the output, the engineered feature that we have earlier, which is the alcohol acidity interaction, is actually in top 10, and this validates our domain knowledge. So another observation is that the type white has the lowest importance, which may be indicate one color is not important as the chemical properties. So that is all for this particular training on the wine quality data set. Thank you.